Are you new to Klipper and that printer.config file is confusing you? Follow along with this video and I'm going to attempt to demystify it for you. Hey everybody, how's it going? This is Patrick with Stacking Layers. Today's video is all about the printer.config file. Before we jump into this, I want to give a big thank you to PCBWay for sponsoring this video, and here's a little bit about them. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWay has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video, and now let's get back to the video. Okay, so what is this printer.config file? Well, easiest way to sum it up is this is by far the most important file that tells Klipper everything it needs to know about your machine. Without this file, Klipper's not going to know what to do, and you're going to get errors and nothing's going to work. So this is probably where a lot of people get confused or get kind of discouraged because they look into this file and start thinking, oh no, I don't know about coding. I can't do this. And so they kind of back out and go back to Marlin, which is fine. Marlin's great. But if you want to try out Klipper, I'm here to tell you that you don't need to know how to code to get into this part and to understand what's happening here. So I'm going to go over the must-haves and what this file is all about. First and foremost, you need to know that it must be named printer.config. A lot of configurations that come pre-made for you have the name of what it's for. For instance, here I'm using the SKR Mini E3 version 3, and so it can be labeled as such, SKR Mini E3 v3.config, but you have to take that file and rename it to printer.config, because that's what Klipper looks at. So basically what's going on is every time you turn on your machine, Klipper will look for this printer.config file and pull all information that is provided by it into its system to make everything work. So that's why it is important to name it properly. And that's probably the first thing I notice a lot of people get confused about. They put it in, they get their configuration, they put that file in, it's like, I don't understand, I have my configurations right there. It's just because it's not named right. So try that first. So three main parts of what are in here, or technically there's only two main things, or one, but I like to break these down into three different sections of what kind of text, I guess, is what I'm trying to say. So you have this light green text that it's in brackets, all of these things, right? Those are your your definitions or your headers. These are the various functions that you then put in, which is the second part, the parameters, to basically set up each one of these things. So for instance, here is your stepper X. This is your stepper motor that's driving on the X axis. And these are the parameters. So this is the first main thing and the second main part. So this is the information that is controlling this. Then the third main part of text is comments. If you're not familiar at all, you have an option of putting text into these files that Klipper ignores. Anything that starts with a hashtag, from that point on, for that one line, is going to be completely ignored. It's invisible to Klipper. It is nothing more than comments or ways of changing information. And it's solely for the user, for you. So for instance, if you want to start playing around with settings, let's, as an example with the stepper X, you want to change your homing speed, but you're so, you don't know what you can or can't do. So you just want to play with the numbers. Instead of deleting what's on here, I mean, obviously 50 is an easy number to remember, but instead of deleting it, all you would do is put a hashtag in front of it, and now you can go back and add it. Say you want to home at 100. You want to go crazy and get a really fast homing speed. You can do it like this and not lose your original setting that you had there. So like a default setting in a sense. And so you do that, you set up and you go and start your homing and you realize, okay, no, that was way too fast. I don't like that. But if you had deleted that, you couldn't remember what you previously had there. Now you're gonna have to start playing around and going back. But if you leave it like this, all you need to do is come here, delete all that. Now you're back to your default. So comments are really helpful. You can also just leave yourself notes, whatever you want to do, you know, hashtag, and this is homing speed. Yeah, you get the point, right? So anything that's after that, but if you notice, obviously what's going on here is only from the hashtag on, so the rest of this line is a comment. Anything before the hashtag on that same line is still going to be seen by Klipper. It's also not going to follow. So if you were to do that and then hit enter and continue typing, it's not going to have this as a hashtag. You have to add another hashtag in front of that in order to make that also a comment. All right. So those are comments. Pretty straightforward. If you were familiar with Marlin, they use the double / on that one. Same principle. It's a comment. You comment. A lot of people say comment it out. That means to comment out. For instance, if you don't want stepper X, that would be commenting it out. You've now turned that off. You've made it invisible to Klipper. That's all that is. Let's get rid of those because those don't belong there. So that's comments. I wanted to point that out because a lot of pre-configured things will have stuff like here in this section. You have these two lines that are commented, right? This 63 and 64. So they have a comment because that's an option that I can use for an end stop. So this would be an end stop pin, like a standard clicky end stop, whereas instead of using that, I've set it up to use a BL touch. So it's using the probe virtual end stop instead. So this option gives me, if I don't want to use BL touch, I don't like it, turn off that BL touch and turn back on that end stop pin. So it's that simple. So instead of me deleting this and then later on deciding I don't like the BL touch, I want to go back to a normal standard end stop switch, then I could do that without having to go through the documents looking up what pin number it is and how was it set with the little up caret, the little up triangle thing, or was it inverted like this, things like that. I don't need to worry about looking at that. I can just uncomment it. So that was that. Let's just get this organized there. Organization is really important with these. That's something I want to stress, that you notice there's like spaces and things are all nicely even and whatnot. They're not, you know, I don't have like this over here and so on. Some things actually, if you have too many spaces, they won't work, especially when it comes to like macros, a G-code macro stuff. That's beyond this video, but they will not work. So spacing is important, but mainly keep things tidy. It helps you in the long run. Trust me, you start doing a lot of modifications, you can quickly get lost in these things. So organization is key. And speaking of organization, that's where we have these up at the top here. These includes. Include is a function that will basically, as it's worded here, will include whatever file you have after that. So you do include and then space. The space now finishes include and says whatever's after that space, include it into this printer.config. Now this is a really great way of keeping things very organized, because I'll show you. For instance, main cell needs to be pulled in order for things to work. But let's go over to main cell, and I will show you why you wouldn't just put it into it. So here's the main cell.config, right? So that include is saying include everything that's inside this file. And you start looking, it's like, okay, here comes the confusing stuff. This is where it's all the weird code and things that you probably won't be used to seeing. These are a lot of different just macros and things. Macros are automated things. So here's a G-code macro, for instance, that says set pause next layer. So this is something to do with pausing on the next layer. So you can technically take this little string of words, set pause next layer, and put it inside of the console and enter, and it'll run everything that's inside here. That's what that's all about. That's what G-code macros are. But anyways, you see there's a lot of information in here, right? Technically, all of this, for it to work, needs to be inside this file. But if you think about it, if you were to copy and paste all that in here, it would become a mess quickly, especially if you have other things you want to include. So instead of doing that, you use includes. That's all it is. Pretty simple, right? And so for organization, not only does it keep things tidy without having to put all this required information inside here, but you can also take out required information. So you have steppers and stuff. Here you have a BLT config I made for an example. This is the BL Touch bed probe sensor, if you're not familiar with that. And I've made that BL Touch config, BLT config. And so this has only information that pertains to the BL Touch, nothing more. So this is a great way of doing organization. You can come in here, and instead of searching through your printer.config file, you can just come here, do your edits. Like say, for instance, the max bed mesh was a little bit too high and you were getting out of bounds errors. So I can come down and change, oh, okay, 220 was a little too much. It needs to go only to 210. That should fix it. Instead of having to go through and find it, you know, in the printer.configuration here, you can just have that other file and then use it as an include and everything's in there. So you can really tidy up this whole thing and make it easier to find things by doing that. Technically, you can have all your steppers in one file, have all your stepper drivers in another file, and just include everything. Just have a whole bunch of includes, and all of this will be blank because they're in their individual files. So not required, but if you want to get really, you know, into organization, it's a really nice way of doing that. So those are the main parts. Certain things that are absolutely required. Now, in printer.config, like I said, you need things to run, of course. But obviously, there's going to be the primary, the backbone of what your machine is that Klipper needs to know about. So you have your MCU. That's what the controller board is, basically. That's the main chip on your controller board. It needs to have the serial or however you're connected to, and predominantly it's a serial. It's when you plug it in USB to the Raspberry Pi, for instance, your Klipper host. This is how it talks to it and who to talk to. So that's required. That's what that's all about. Then you have your printer information. There's your definition header of printer and the information about it. So you have your kinematics. That is what style of printer. This is a Cartesian. Cartesian printers are like Ender printers. So it's the X, Y, and Z motors are all on their own axis, not integrated together. So if you have something like a Core XY, like a Voron machine or something like that, a lot of the new machines are coming out that are being Core XY. That's where the X and Y axis are controlled by two motors, but both motors have to move in certain ways to get things to move, either X, Y, or diagonally. So this is basically telling it what style of mathematics is being used to control your machine. And then the next two lines here are your velocity and acceleration. This is your maximum speed limit and your how fast you can get to that speed limit. So these are where a lot of people start coming in and playing, because of course Klipper, a lot of people come to Klipper because they want to make their machine go faster. This is where you do that. One of the spots. There's a lot more involved. It's a lot more technical than that, but I wanted to point this out because I see people messing with this and not understanding what's going on. So with the printer max velocity, this, like I said, is your speed limit. So to give an analogy, imagine driving a car. Your max velocity is the speed limit, the set speed limit for the area. And that would be, you know, how fast your machine can move. And so say it's set to 50 miles an hour, you can only go to 50 miles an hour. But the acceleration is how hard are you going to step on the throttle as to get to that 50 miles an hour, right? And so these two things really do work together. So say you can have a 300 velocity, or sorry, yeah, max velocity, but if you only have 100 accel, it's still going to take a while to get to that because you're just lightly touching the pedal on the throttle and you're just slowly getting up to that speed limit. Whereas if you have 5,000, now you're stomping on that pedal, and whatever your engine's capable of doing will get you to that speed much quicker, of course. But then just like in a car, the motors can have problems having too much acceleration. If you're in a car and you have a car with a motor that's powerful enough, if you step on the throttle all the way, you can spin your tires, right? Do a little burnout. That is an equivalent on your machine, your 3D printer. That would be considered skipped steps. That's a term that you probably heard. Skipped steps causes a lot of issues, mainly shift layers. So if you have an issue where your printer's pumping along and going fast and you're like, yeah, my printer's nice and fast now with Klipper, but then you start occasionally having these issues where your print, it seems as though your printer has lost its its position and it's moved over. So now it's printing to the right a couple millimeters. It's still printing, but the entire top part of the print has shifted. That's mainly due to the fact that your acceleration is too high. You can go too fast. You can be stepping on that, because basically what you're doing is causing your printer to burn rubber, metaphorically, and missing steps. It's just like with a car. When you're burning rubber, it's not moving forward. It's just spinning the tires really fast, and but it's staying at the same spot. And so like that, with too much acceleration, you can have skip steps. Another thing that too much acceleration will cause is the ghosting. Now, Klipper does have the input shaper available, which does help to compensate for that ghosting or ringing, or what it is when you get the pattern of your 3D printer. Let's see if I can pull up real quick. 3D print. Let's see, lots of information about that, of course, but let's go to images, because that will give you the pretty obvious what's going on. So when you get these type of lines going on, that's ghosting. That's predominantly caused by too much acceleration. Way too much acceleration is going to cause that going on. And then, just since I'm here doing this, layer shift. If you're not familiar, if you are, skip ahead. Forgot layer shift. This is layer shift. So you got these type of things happening. All these weird ugliness going on, things flipping back and forth. This, again, can be caused by too much acceleration because you're causing missteps. Again, to sum it up, the misstep is going to cause the printer to not know exactly where it's located anymore. It's going to think that it's still printing here, but because the skip steps didn't let it move, now it's printing here. Okay? So I just want to point that out, because this is something I've seen a lot of people mess up with, and since we're in the printer.config, that's where you change that. You can change it on your dashboard right here for your machine settings, and you can set this, for instance, to 200. For instance, you want it not to go so fast, or you want to get your velocity up to 5,000. Okay, you can change them here, and that's great, and it'll do it. So you do 5,000, hit enter, and then you can see here it set the velocity. This is your console. This is the command it set to change the velocity to that. Sorry, acceleration to 5,000. But you come back into your printer.config file, and you'll notice it's still 500, because this is the default settings. So if you restart your printer without saving anything, then it'll go back to doing this. So that is one way you can do for testing out. You can do it, before you set your primary printer.config, you can do it here, and it'll work. And as soon as as long as you don't do any save commands or anything like that, or you don't save it in your printer.config, this will go away next time you restart, and it'll go back to default. Let's see, what else is there? I guess the quick breakdown of what these things are here. So more of the requirements. Let's go back over. The printer, because like I said, this one is set to Cartesian, it must have things met. So with Cartesian, you have X, Y, Z, and E, or extruder. So you have to have those, and that's what these are. So you have your stepper, there's your X, your Y, your Z, and your extruder. Okay? Extruder is a little bit more involved, because it's not just a motor, but extruder is also taking care of the hot part of things. So it's also your nozzle, your hot end area. So you have your first part is your extruder information up until this line. That's telling the pins that control it and the rotational distance, so how much it needs to move material. Then you have your nozzle diameter. Not dramatically important, but I always recommend just match this to whatever nozzle you have. So if you change out to a 0.06 nozzle, for instance, sorry, 0.6 nozzle, go ahead and change that to 6 there. Filament diameter. Most of the machines we use these days are going to be the 1.75. Just put that. But if you have another machine that's using the thicker, the 3 millimeter or 0.2 something or whatever, make sure to have that proper filament diameter. So if you're having extrusion issues and you're like, I've done my rotational distance, done all that, check these things and make sure that they're right, that you don't have, maybe you have something here and you accidentally changed something and you added a digit there or something like that, or you've accidentally taken away a digit or something. So make sure that those are correct. Sometimes when you're going in editing, you can accidentally click something like that and erase part of a number, and it won't give you any errors, but you can find out that, oh, my filament diameter body only says 1. That's obviously not going to give you the proper extrusion. Next up on here is for your extruder, you have your heater pin. That's the heater controller for the actual heater in the hot end. And then you have the temperature sensor, what type of sensor it is, and then what pin it's talking to, and then what style of control system that is being used for the extruder. PID is a newer system, or not newer, but it's for newer, more capable boards. Older style boards that don't have pulse wave modulation use another thing that's called watermark, you might see here. Some old boards, like the 8-bit boards, have to use watermark because they only have the option to turn on and off like a standard relay, just straight on, and then once it reaches the temperature, it turns off. PID is a little bit more controlled, and it uses logic to go with these 3 parameters. You don't really need to know a lot about this because there is a setup in Klipper that you can run a calibration, but that's what the difference is. If you see PID or watermark here, that's the difference. PID is a finer tune, and watermark is more of a older called, like they call it bang bang, because like an oven at home where it just turns on, and then once it reaches the temperature, it turns off, and then it gets too cold, it turns back on, reaches temperature, turns off. So that's what watermark is. If you ever see that on older boards, just want to point out because not all boards can do PID, but most new boards can. Okay. Then let's go back up here with your steppers. You also have stepper drivers. This board in particular has the TMC 2209 stepper drivers on them, and they're also set up to be used by serial UART command. So that's why there is an additional here. Certain like reality boards have TMC 2209 or 2208 stepper drivers in them, or something equivalent, but they do not use this section because they're not set up to use the UART communication, the serial communication. So they still cannot be controlled. You can't, back up real quick, the advantage of having UART control is that you can, for instance, set your run current and tell it exactly what current you want to max out at, or whatever it needs to be set to. Whereas other boards that don't have UART communication, they're set in standalone mode, and that means you still have to use the little potentiometer, you have to use a screwdriver to adjust your V reference on the boards. So just keep that in mind that not all boards have this available. I think like a lot of the older Creality boards don't. They didn't, I don't know why, but they didn't plug it in to work that way. So having this on there, you may not get any errors, but it's going to be irrelevant. It's not going to actually do anything. So do keep that in mind. Or on the other hand, like for instance, this the ESP Mini, SKR Mini E3 boards, they do have that. And so if you forget to set this up, then it'll default into a kind of a standalone mode. But because there's no potentiometers on there to adjust, your current is not going to be proper for the board. So you do have to have that on this board. So wanted to point that out. That's what that's all about. That's what stepper driver controllers are. And then the way they're set up, kind of like with the include, it's the include, and then whatever's after that is what it's including. So this one is this driver, which is a TMC 2209, is going to be controlling this stepper. So stepper X, which is obviously this one right up here. And you can see how when you highlight that one highlights up there. It's to kind of show you that it's a match. Same thing here with stepper Y. This one is set up to control that one, and so on. Z and your extruder. So that's what those are. If you have a heated bed, that would be heater bed, and the underscore is showing that this is not name. This is actually all one definition name. If you have a space there, it's completely different, but if you have this heater and bed, this is defining a separate heater and calling it bed. So it's not specifically your heater bed, your bed heater. And again, kind of the same thing as the extruder, but without any motion. This is purely for the heat part. So you got your heater pin, what kind of sensor is listening to it, what pin it's on, and then what kind of control system. You also have, I didn't point out in the extruder and stuff, but extruder and heater bed, you have these min and max pins. Now you may see that there is a -200. Do not use that information. Do not ever put a minus here. This is purely for this demonstration so I don't have errors, because I do not have a sensor plugged in. That's the only reason why that's there. Leave it at like 10 degrees or higher. This is going to be the minimum temperature. Anything below that temperature will cause your board to turn off. If you have a minus temperature here, a break in the wire could cause a minus temperature. Actually, it does with this, causes like a minus 99 degrees. But that's an actual break in the wire because there's nothing connected right now. So it's the equivalent to my wire being cut, broken, sensor not operational. If you have that, a minus number here, and you actually do get a break in the wire while you're printing, you can go into a fire situation where you're getting a thermal runaway and the system may not properly recognize that because you're telling it, don't worry, minimum temperature is still safe. And it may be actually heating, but because it thinks it should be fine with that low temperature, it won't know that something's wrong. It won't know that there's a break in the wire, and you can cause a fire. So there's other things. Thankfully, Klipper has other things, other checks and balances to where that probably won't happen, but I'm going to stress, don't put minus numbers in here, okay? This is solely for demonstration, so I don't get errors when I start this up with nothing plugged on my board. Anyways, max temperature. Max temperature is your maximum allowed, obviously. Pretty simple, self-explanatory. So for your extruder, it's going to be higher than your bed. But if your extruder has a maximum temperature you're going to print at, say, 220, give it a little bit of extra, like 10 or 15 degrees more over. That way, when it's going through its initial heat, that if it goes up above that for a few seconds or so, it's not going to be dangerous. But if you don't set it, if you have it set to your max, and say 230 is your max, right? And you set your temperature to 230, you're within max temperature, but it's going to overshoot a little bit. And that, if it overshoots for too long, it'll turn your board off. And so you just keep getting these errors. So just give yourself a tiny bit, but not a lot. Don't put 400, 500, because if your system's not made to do that, again, that's a fire hazard. So I wanted to point those out. So that's what the heater stuff is all about. These are your fan controls. Fan, with just the name fan in here, is your part cooling fan. That's something that confuses a lot of people. The rest of this stuff are other options. If your board has multiple ports that can control fans, then you can use these. Otherwise, they're normally considered what are called always-on fans, and those are fans that are connected to voltage directly, so you have zero control. But here, these are fans controlled by heater. So for instance, on this one here, this is heater fan on the nozzle. So this is the, I have it set up to the fan that's blowing on the heat sink that's for the heat break, so to keep the cool area of the hot end cool. And that's designed to turn off if the extruder temperature is under 30 degrees, or actually it turns on is the way it's actually worded. This is the pin it's on. It's looking at the temperature of the extruder up here. Once that temperature goes over 30 degrees, it'll turn that fan on. That's what that is. And there's multiple fans, multiple ways of defining fans. But like I said, these are only available to play with if your controller board that you're using has extra controllable fans. With the keep saying that. The SKR E3 Mini does have it. They have 3 controllable fans. I believe that was correct, yeah. But do point out, this is a single fan. If you have multiple fans for your part cooling fan, you do need to wire them in parallel. So I did also want to point that out, because some machines have multiple fans, but they do need to be wired in parallel because only one pin can be defined in this section. You have your display information if you're going to be using a special display. Also want to point out that Klipper does not have actual touchscreen, even though it says touchscreen here. They don't have a dedicated touchscreen interface. It's purely a rotary style basics like the Marlin look. But any of the touchscreen systems, I'm sure you've seen things that show touchscreen with Klipper. That is called Klipper Screen. That is not actually controlled by Klipper. It's a separate program that is communicating to Klipper. So this type of this type of screen information display is for the non-touchscreen style information, okay? This section here, this is just something that a lot of manufacturers are putting into their boards. When you have an EXP plug, those are those plugs that screens are normally plugged into. So this is just a way of giving aliases or different names to pins. So you have these pins that are inside of that. So the EXP1 header, which on this board only has 1, some of them have EXP1 and 2. They're 10-pin plugs. And so that's what these are. So it's basically saying for the first pin, pin 1, we're naming it this, and it's connected to that pin. And so pin 2, 3, 4, 5, and so on. And so you can use those instead of using the pin numbers. You can use here EXP1, as you see down at the bottom here. This is a beeping pin, so this is just a standard random output. So this is pulled high when it's called, and so it's called the beeper, and it's that pin that does it. So basically, it's just saying that this pin can be controlled by something called beeper, and it's an output, so it'll send a high signal. So that's what that is. These things aren't required at all. They're just things to make things organized and make things easier for configuring later. But that's what they are. If you see those in there, it's not absolutely required for anything really, unless it's been used, of course. Then you do have to have those. Keep in mind that sometimes these things can be in a completely different file. Remember, the include, if it's an include and you have include board pins, make sure that that's in there. Some people do organize their files that way, and they'll have a board pins config. So you do need to include that in order for configuring. All right. So that's the bulk of it. That is pretty much what things are. This is the absolute minimum of what's required. Like I said, you have to have an include of your main cell, or if you're using fluid, you'll have to have the fluid configuration because it does need that information. The rest, any other includes that you want to add. Then you have to have, in a roundabout way here, you have to have your printer, what kind of printer it is with your velocities and whatnot. You have to have your MCU, that's so it knows who it's talking to. And then you have to have your motors, all the different controls of your motor. So if it's a Cartesian motor, you're going to have an XYZ and an extruder. You don't have to have heater bed, but if you have a heater bed, obviously you want to define that. You don't have to have fans, but again, you're going to want those, of course. So if you have controllable fans, you have to set them up. And then that's the bulk of it. That's all that's absolutely required. Everything else is just setting it up. For deeper information on here, let me know down in the comments if you want a more detailed video about what this is. For instance, if you need me to go over how all this stuff works, there is a lot involved. I didn't want to make this video too long, but like I said, I can tell you more about them. So maybe I'll make more videos that just pertains to how to set up Stepper X, for instance, to kind of keep all of these videos shorter and easier to digest is what my plan is. So let me know if that's something that you would like to see. You always have the Klipper reference section. So it's klipper3d.org/config references. I will put this link down in the description because this is really where you're going to learn everything, what all the different stuff means that can go inside these configuration files. So here's your MCU. It tells you what's required and so on. Okay. So this is something I recommend to everybody. Come to this, read as much as you can, take it in sections if you want to. Because this is going to give you so much information about what's needed and what's not and what they actually do. It's still going to be confusing, and if so, leave me a comment, ask questions, and I can help you as best as I possibly can. I'm still learning a lot of this stuff too, but I feel like I got a pretty good grasp about it now. I can set up these machines fairly quickly for the basics and get things moving along and do some more advanced stuff. So hopefully I can portray that information to you in the future. Again, that's it for this. I don't want to make this any longer. Another big thank you to PCBWay for sponsoring this video, and a huge thank you to all my new subscribers. I see you guys coming in. Thank you so much for enjoying this information and finding it helpful. I'm more than grateful. I'm getting close to that 1,000 subscriber mark, which is just remarkable. And once I hit that, I think that YouTube starts giving me some sort of revenue so I can actually collect more items to do more stuff. So let me know what kind of things you would like to see. Like ways of how to configure other sensors and stuff like that, so I can try to buy those if I get some cash for that from this. I don't know how that works yet, but anyways, that's what that's all about. Thank you, and until next time, happy printing.